Okay, well, welcome everyone. My name is Nitin Vaidya. Before I start with the talk itself, some caveats. This is a talk about how to read, write, and present papers, and not everybody agrees with what I have to say. At least a couple of slides, there is some, disagreement on those. So you should use the advice at your own risk. And I'll say that even I don't follow my advice all the time. I try to, but not all the time, and sometimes I don't follow it to my own regret. Okay, to make sure you end this talk happy, I want to lower your expectations just a little bit. The topic of the talk is fairly obvious, I think. And so I'm not going to tell you anything that should be surprising, at least in the hindsight. So pretty much everything I had to say should be common sense, and things that I have made mistakes about and then corrected them over time. So, people tend to make some of these mistakes, even though it may all seem very common sense anyway. Okay, so the talk is about reading, writing, and presenting papers. So we'll start with reading, and then we'll talk about the other two. So we're talking about reading papers first. This is the part which is the first section that will be the least sort of surprising, hopefully. So why would one read papers? Not surprisingly, you need to read papers so you know what's happening. One of the reasons you want to read papers is so that you don't reinvent something that somebody did last year or last 2 years ago, or sometimes 20 years ago. That happens too. People do reinvent things all the time, and it's happening more and more lately because you have different sub-communities working on the same set of problems, and often without paying attention to each other's work. And that's what often causes people to reinvent things. And of course, you can find some interesting questions when you read these papers that you can pursue yourself. Okay, so that was why read papers, so not surprising. Why not read papers? You cannot read everything. There is just too much stuff out there. And more importantly, not everything is worth reading. If you look at a typical conference, there are 50 papers to sometimes hundreds of thousands of papers. Most of them you don't need to read. And if you look at all the conferences and journals, there is just way too much published. Most of it is worth ignoring. So you have to know what to read. And the other sort of secondary reason to not read just pretty much anything that comes along your way beyond just not having the time for it. Sometimes, at least for me, I find it difficult to think outside the box. If I have seen somebody else's solution, I get influenced by that. And so sometimes I find it actually useful to start thinking on a solution even before I know what somebody else has done. So you need to do both, but yeah, so don't try to read everything that's out there. So of course you must read. Not reading is not an option, but you need to know what's important, what you can ignore. And when I say what's important, given that there is so much going on out there, it's not as if you can go and look at every conference proceeding and then look at the papers and say which one I should read. That's one option. I do that for my sort of the main conference in my area. But otherwise, I usually know which people I should look up. And I go check them out every year or 2 years and see what they have been up to for the last year or two, and just try to read their work. I know these are good people who tend to write good papers. And so this is how I keep up. The other way I know what to read is when somebody comes and tells me that, Nitin, you ought to read that particular paper. And that's very common in my case. My colleagues, either here or elsewhere might tell me to read something. And that's how I know what I want to read. But if you're sort of just trying to scan for literature, then major conferences is the way to go in computer science right now. There are some very good journals, but they're many years behind. So that's not where you'll find the latest work. And for really current research, you need to look at tech reports. For example, in my area, we publish reports on arXiv. There are other places that people publish as well. And again, if you're going to look up arXiv, there's just simply no way to look at every report that appears even in your own area. There's just too many of them. And again, you need to know who to look up. And this particular point I want to come back to later on, because if I am reading papers by identifying the right people to read from, when you write papers, you want others to look up your papers too, and you need to be in that short list of people they look up. Otherwise, those papers are not going to be read. And the other type of papers that are useful sometimes are survey papers. I see less and less of that lately. When I was a grad student, there was a very popular journal, Asian Company Surveys. It's probably still around, but at least those papers don't seem to be as popular today. Now, most of us have this tendency to read papers on topics that we are working on, which is natural. But sometimes it's very useful to be reading papers on things that are far beyond what you might be working on. There are many interesting ideas at the intersection of areas that may appear different to you, or certainly the area, actually I'll give an example on the next slide. The areas may not seem connected, but once you understand things better, you find connections, and there are very interesting things at the intersection of these sub-areas. So in the same vein, you should attend talks that are well outside your area of interest. In fact, attending talks is the most sort of productive thing one can do, because the speakers are spending a lot of time preparing the talks. They'll give you an overview of the area and so on. And in 1 hour, you can get a lot, far more than you can by trying to read papers for an hour or so. And same thing with courses too. So in my own case, my research area today happens to be distributed computing. I used to work on wireless networks a long time ago. But what I do today, for the most part, is motivated by some work I have seen in distributed control. And that's because of some of my colleagues back at the University of Illinois a few years ago. Got me thinking about some of the issues that they were working on. And I was able to find pretty interesting questions at the intersection of these two areas that we still work on as of today. In fact, a lot of my research is motivated, sort of driven by things I learned maybe 6 or 7 years ago from the control theorists. And this is not something I would have expected to be connected to what I do in computer science, but the connections are actually very strong. And I'm able to find rather interesting questions there. And this can happen to most of you if you look a little bit beyond your narrow scope of research. So we're talking about reading papers. So I think most of you know the answer to the question here, what's in a paper? It starts with an abstract. Abstract is a good way to learn very quickly what the paper is about. If you don't care for all the details, abstract is the thing to read. And there is an introduction, motivation, background, related work, problem definition, solution, right? Evaluation, conclusions, future work, stuff like that. So what should you read? So if I'm just scanning my conference proceedings for the year, then I tend to do what the first item here says. I tend to look at the titles, and the abstract, just to see what the paper is about. I try to remember who the authors are, because even if I may not see the whole paper today because it doesn't seem interesting, I want to be able to go back to the paper maybe a month or 2 months or 6 months later, and then it helps to remember who those authors were. And typically by authors, you might remember the senior authors, like the faculty authors on that, because that tells you which group the paper is coming from. It makes it easier to go back and look at any follow-on work they may have. If the paper is in sort of closer to the type of questions that you are working on, then of course you want to read more. Not necessarily the whole paper, because there is just too much detail that may not be relevant at the point that you're looking at the paper, but everything but all the details, right? You want to the high-level ideas, conclusions, and so on. So what should you note? I already mentioned the authors. I find that's for the most important thing I can remember when I'm looking at the paper for the very first time, because then I know what to go back to. But otherwise, I try to look at what type of solution they're proposing, not necessarily all the minute details, but the high-level idea. If the paper is written well, I can get all this in the first 2 or 3 pages. And when we talk about writing papers, I will come to that too. So usually I don't need to read more than 2 or 3 pages if the paper is written well to get everything that this slide should note. When you read one paper at a time, it's sometimes hard to see the big picture, right? You're looking at one particular paper, one particular idea, and their results and so on, and you can easily get caught up in the details. But as one looks at many papers, then hopefully a bigger picture emerges. And it might take some effort on your part actually to identify that big picture, meaning what is the space, right? What is the problem space? Often these papers are not solving the exact same version of the problem. They are looking at different versions of the same problem. And it helps to get a feel for what the entire space looks like for the problem as well as the solution. And when you have that big picture, then it becomes easier to identify the missing pieces. So for example, it could be that the research so far is missing one particular part of the solution space already, or there could be a version of the problem that people haven't looked at that's interesting. And this is again where getting a bird's eye view of the area is very useful. So this is something you should be doing when you read papers or attend talks, right? Observe what you don't like about the paper. So yeah, borrow ideas from other people. If you see them doing something right, you can try to borrow those ideas. And if you see them doing something wrong, don't do it yourself. It's very simple. Here are some questions I want you to think about because this may affect how you deal with when you write papers. So I'm not going to try to answer this for you, but this is something you can think for yourself. So when you decide to read certain papers, how do you decide which papers to read? Or if you take a class, like a seminar class, and the professor assigns you a list of 20 papers from an area which may be publishing hundreds or thousands of papers in a given year, how do you suppose they come up with that list of 20 papers? And from your own standpoint, you're reading some number of papers in a given year. How many do you read? It's a very small fraction if you start thinking about it. And a related question to that, how many of your own papers you expect someone else to read in a given year? So let's say you write 5 papers. How many of your papers do you think I'm going to read, even if I'm in your area? We'll come to that later, but this is just something to think about in the longer run. So let's talk about writing papers then. So how do you write papers? The answers are quite simple here as well. Do what you expect everyone else to do when they write papers. But let's drill down just a little bit. So, we all write papers. If the paper you're writing is something phenomenal, right? You've managed to prove people to NP or something like that, or maybe not that far, but something quite exceptional. Maybe it doesn't matter a whole lot how well you write it. And by that, I mean, maybe on the other hand, if your paper is not that exceptional, and most papers are not that exceptional, right? They tend to be fairly incremental. Then writing makes all the difference. Writing makes all the difference between papers that are accepted at a conference versus not. It makes a difference between whether somebody reads the paper or not, and so on. So what I'm going to give in the next few slides are just my sort of rules of thumb and my thoughts on how to write a good paper. Like I said before, not everybody agrees. So this is just my mental model for a good paper. And you can take what you want from it. So one rule of thumb I follow is to assume that I have only 3 pages, the first 3 pages of paper, to convince you as the reader. And in this case, the reader might be a referee who's trying to decide whether to accept the paper or not. It may be somebody like you in my area who is trying to look at the paper and deciding whether they should read the full paper. And I give myself 3 pages. And by 3 pages, I don't mean 3 10-point font, double column, 3 pages. I'm talking about single, column, 11, 12-point font, 3 pages. And usually, if you think in this manner, it's possible to write the paper so that you can actually convince somebody to believe that you have something interesting to say in the rest of the paper. So in 3 pages, you can give them the problem definition, why it is that you're working on it, what's the innovation, right? What are you doing that is improving on the previous work in the area, what results you have, what is the significance of those results. It's possible to do this in about 3 pages if that's what you're aiming for. And if you think of a conference referee, they have to like your paper to accept the paper. A typical referee may be reviewing between 10 and 40 papers for that conference, depending on the conference. So talking about hundreds of pages, and they have maybe a month to 6 weeks to do this. So the reviewers get fairly impatient when they have to read that many papers. And you should do whatever it is to make it easy for them. And so this is what I do. So in my papers, typically, at least when I submit for reviewing, if you can read the first 4 pages, you know what the paper is about. And then you can make a decision on whether you want to read more or not. The other rules of thumb is that it doesn't matter what the paper is about, it should be easy to read. There should be no ambiguities. And by ease of reading, I mean that I don't mean that the results should be easy. So it's possible that the results are quite complex. If you have a theoretical paper, the proofs may be non-trivial, but the complexity of the results should not imply difficulty of reading the paper. It should still be easy to read, even if you're presenting complex results. On the one hand, there should be no ambiguities, but on the other hand, there should also be no unnecessary redundancies. So when, of course, these days I don't have as much time to edit the papers with my students, but when I do have time, I usually look at pretty much every word in a sentence and ask whether it is needed. If the sentence has 15 words, and if I can write the sentence with 10, I will go back and rewrite that sentence with 10 words, because why have more words? Because the reader has to do more work if there is unnecessary redundancy in the paper. I like the papers to be easy on the eye. So when I'm reading a paper, if it seems very dense, if the white space is not there in an adequate amount, then it's just very hard to read papers, and people get annoyed actually if the paper is not formatted so that it is pleasing to read. And the final item, I will come back to this, there is a running theme here, but quality beats quantity. And here I'm thinking in terms of how many papers I might write. So if I would rather write personally a much smaller number of papers that is very well written than a larger number of papers that is not well written, because I know that the only papers that somebody's going to read are the well written ones. And so I'd rather just have fewer well written papers than having a lot of papers that nobody's going to read. Just so you know, most papers are not read. There was a statistic I heard from my previous University of Illinois library system. This is many years ago, that they reported statistics on what fraction of the books are checked out from the library. This is at a time when we all used to go to libraries and check out the book. It's a very small fraction. And it's the same with papers that are published online, right? Most papers are not being read by very many people. And so one has to make sure that your papers are in that small number that other people are reading. Looking at it a little bit further, in computer science, for better or worse, we have this divide. Actually, I believe it's for the worse, but there's a divide between theory and systems. So let's talk about a theory paper versus systems papers. I write more theory papers today than systems. But often people, when they write theory papers, they get mixed up between formalism, which is where you're trying to be precise about your notation, your ideas, the results, the theorems, the proofs, whatnot. That's what I mean by formalism. And they sometimes get confused between that and readability. So even if the paper is very well written, as in formally, precisely, it should still be very readable. It should be a pleasure to read. The papers, just like you read a novel, it's fun to read. That's why I keep going forward. It's the same with technical papers as well. There is no reason why technical papers cannot be fun to read. In a theoretical paper, sometimes there's a temptation to provide the formal results quickly, but it's much more useful to provide the results intuitively before one states them terribly formally. Again, this sort of fits in with my earlier notion of trying to do everything in the first 3 pages. It's hard to state some of the results formally in first 2 or 3 pages because it may need much notation. And but sometimes it is possible to state them informally early on. So that's something worth considering. The proofs, like I just said earlier, they can be complex, but they should still be easy to read. And this is possible. This can be done. If you think back on papers you have read over the years, you'll probably remember some papers being really nice to read and some were not so nice. And it's not because one paper had easier results than the other. It's just because the authors of some papers spend more time thinking about how to write the proofs and others don't. Now, most theoretical papers will have a number of proofs. And some proofs are important, some are not. So you have to decide which ones are and which ones aren't. And put the less important stuff in the appendix. Because any proof that comes in the middle of a paper is going to break continuity. And of course, sometimes that's worth doing because the proof is very important. But you have to make a judgment call on what needs to be in the middle of the paper and what can be at the end, or what should be at the end. And secondly, proofs are themselves not that as interesting very often as if you have a new proof technique. That's very interesting because somebody can adopt that technique for their future work as well. For systems paper, one weakness I see repeatedly is that the authors don't tell me how they produce their empirical data. Right? Typically, you know, if you have a CS systems paper, they're going to evaluate their algorithm on a certain system. They might be using certain data sets, right? There's a fair amount of detail that matters to their evaluation, and authors often don't provide it. And of course, reviewers expect that, so that's important. But even more importantly, if somebody wants to improve your work in the future, they want to compare themselves with what you did. And they cannot do that unless you tell them what you actually did. The second item here may seem kind of silly. Do not provide wrong information. That seems rather obvious. But people do that actually more often than I would expect. Either probably because they're doing cut and paste of text from one paper into another. I don't know exactly why this happens, but people do provide incorrect information every once in a while. And not everything, sometimes, not everything can be included in the paper, either theory or systems, in which case you might want to have a tech report that provides more detail and provide a pointer to that report in your paper so people can go and look at all the stuff. So most papers should have, or most papers, if not all papers, will have some discussion of related work. And every once in a while, you might see an author who spends most of the space talking about their own previous work, which is fine if it is relevant. But I think it's a good habit to talk about the work of other people too. There's always somebody else who has worked on that before you. And the related work doesn't have to be exhaustive, it's not realistic. But it should cover the space of the solution that have been discussed in the past. Even if you cannot cite every paper, cite the representative papers. And when you compare yourself or just provide opinions on prior work, use language that is not offensive, because that particular author might be reviewing your paper too. So don't offend people unless you feel some necessity to do so. I hope you don't. The last line there is a good advice, I think, for everything, not just for papers. But people seem to violate that all the time, actually. Okay, so I think I said this once before, do not irritate the readers. This happens all the time. This is one single reason I don't read a lot of papers. That I start reading, I stop, because when I read a paper like for a page or so, after a while, it's just not realistic for me to continue. It just takes too much effort on my part. And sometimes it is about the notation. The notation is not defined clearly, or the notation is just very strange. I cannot keep up with it. We talked about long sentences, did we? I can't remember anymore, but so those become hard to follow. The last issue here happens repeatedly. So when folks write papers with results that may not be very strong, there is a tendency to write the paper in such a way that it's not obvious that the results are not strong. Now, if the reader knows the area, they'll figure this out anyway. And trying to hide that essentially behind poor writing doesn't serve any purpose at all. So my suggestion when the results are not very strong is to just admit to that, right? Point out the weaknesses of the results. That's okay. Not every paper is going to have the best possible results. As long as they improve on the state of the art, that's useful. But if there are any known weaknesses that you know about, I think those should be pointed out to the reader as well. So partly, if you're willing to point out your own weaknesses, weaknesses of your own ideas, then when you tell the reader about the strengths of your ideas, that also becomes more believable. And the readers like balanced presentation. A lot of people don't like to talk about the shortcomings of their ideas because they feel like maybe the reviewer will reject the paper or something like that. That's usually not the case. In fact, the reviewers probably like the paper more because you give a balanced presentation. I mentioned tech reports once or twice in passing. So in my own work, we publish tech reports all the time. It's fairly easy to do. For example, we publish them on Archive. One reason for doing that is that once you have a tech report, then you can circulate that to people from whom you want to get feedback. These are the people who you might trust to give you good feedback. Secondly, it puts a timestamp on your work too. Many of us work on problems that are quite interesting to a lot of people. And if you produce the results today and then the paper takes 9 months to publish, if there is no documentation of the results, then you might lose the claim to that line of work. And so having a tech report at least puts a timestamp on your work. And finally, tech reports, you can include a whole lot more than a typical conference paper can. And usually, there's always a lot more to say than a conference paper can allow you. At least most conference papers are, page limited. So tech reports let you publish more, provide more information. So quality versus quantity, and this is the issue where there is some debate. Not everybody agrees with what I'm about to say. So, so I have been in academia for maybe 30 years now. I got my PhD, I can't even remember anymore, 92, 93. It's been a while. And if you go back to those days in computer science, the number of papers being published per sort of, let's say PhD students was much smaller. Today, the number is much larger. And in fact, the resumes we see occasionally from fresh PhD students that have the same length as some resumes that got tenure many years ago. And the second thing that's happened since then is that we have an enormous number of conferences that are all claiming to be top tier. And not all of them are actually that good. And there is a tendency to believe that the more you publish in top tier conferences is somehow better. And by some measures it is, because if I look at a resume with a lot of papers in these so-called top tier conferences, then there's a higher chance I'm going to look at that resume further. So there's some value there. But there's also a negative. And the negative is that when somebody has a ton of papers, if I choose one of the random papers to read, unless they're all truly high quality, and by that I don't mean where they appear. Venue is not the measure anymore when I read the paper. I make my own judgments. And when I pick a random paper from these top tier conferences, if it is not good, I'm not going to go look at a second paper by the author anymore. And so what I'm trying to say is that given that I'm going to look at, and not just me, anybody is going to look at a very small number of your papers or my papers for that matter, it makes sense to have most of the papers high quality so that the random paper has a high quality. And again, quality is not the venue, quality is the content of the paper. And so this is where this issue of the question I posed earlier, how many of your papers do you expect someone to read in a given year? The number by my estimate is very close to zero. Most people are not reading my papers at all, even if they're in my space, and the ones who are reading, maybe they're reading 1 or 2. That's the typical number. Given that they might read 1 or 2 papers, why am I writing 15 papers in a given year? Why not focus on 5 or 6 really good papers? And so this is the one, like I said, you will see people disagreeing with, but I think it's time that we start writing fewer papers that are better. And a related question to that, this also, there is some dispute over. I have had arguments with a lot of people over time about this. If a paper is easy to write, right? Easy as in, but here's what I mean by easy. When you think of the problem today, you think of a solution a week from now, in 3 weeks you have the data, in 6 weeks you wrote the paper, right? Maybe in a span of a month or 2, you went from the question to the paper. Is that paper worth writing? And I'm not presupposing an answer. Sometimes it is worth writing. Just because it was easy to write doesn't mean the paper is not interesting. But my judgment is that most of the time it is not. There are a small number of papers that one can write in a span of months to 2 months that are worthwhile. And one has to use judgment to decide which ones to bother spending time on, which ones not to bother. And again, this is a bit beyond just how to write papers, but it's more about what to write and getting into the realm of how to do research. Maybe this is something to debate in another talk, but think about it. Okay, so I want to move on to presenting the papers now. Okay, how do you present a paper? Nothing new. This slide you saw earlier for writing. The same thing applies to presenting the papers too, right? Present the talks as you want others to present the talks, right? In a way that is clear, concise, not boring. So why am I giving a talk? Not this talk, but when I present a talk at a conference or something like that, right? What am I trying to do in a conference presentation? At the highest level, I'm really trying to make sure that people pay attention to my results. It's an advertisement. given that the conference attendees are attending, who knows how many talks in a given week, their attention span is quite limited, and you have to figure out how to get their attention. And that's what the rest of the slides are about. But some of these things apply to any talk, not just a conference talk. The second bullet, I have come to it from experience. There are a couple of talks I have given over my career that I still regret. And one of them was an invited talk at a pretty major conference in my area in 2010. I don't know if the audience remembers it, but I remember it because I thought it was a spectacularly bad talk. Hopefully the audience has forgotten by now. I haven't. And it was bad because I was new to this space, and I got asked to do an invited talk, which is unusual actually for somebody new. And I decided that what I had to do was impress my audience by telling them everything I had done. And yeah, that wasn't a good decision. So the goal has to be to communicate your ideas well and let the results speak for themselves. Don't try to cram things into 1 hour or 20-minute talks. Communicate only what you can clearly in the time that's available. Actually, the other talk, I mentioned 2 talks, so maybe I should talk about the other talk too. So I moved to Georgetown 2 years ago, but I moved to the University of Illinois before that in 2001. And I actually interviewed in many universities. I think it was like 11 or 12 universities at the time. And I got jobs offers from all but 3 universities. And the only distinction I know of between those 2 sets was that the 3 universities where I did not get the offer from, I gave one particular talk. And the other 8 or 9, I gave an entirely different talk on a different set of problems, delivered differently at a different level of detail. And the outcome was entirely correlated with the talks I gave. There is no other, this is 100% correlation. And so how you deliver the talk can make enormous difference. In my case, it made a difference in where I got jobs actually. So yeah, things matter. So what's the objective of a talk, particular conference, or even here? You all had lunch just recently, I suppose. So you have to keep people awake, right? At a conference, for certainly, that's very important. People will get tired listening to other people speak. But having done that, having kept their attention for the 20, 30 minutes or an hour that you have to speak, then the remaining goal, the most important goal, at least in my view, is to tell them what problem you're working on. So even if they don't understand your solution and the rest of the details, if they understand what problem you're working on, then they can always go open the proceedings and do the remaining details if someday they want to know more about this work. At least they know what the paper is about. And once you get past that, then you should tell them about the main claim, hopefully intuitively, rather than all the mathematical detail. And if there is time, then you can get into further details such as telling them about your solution approach and so on. All the messy details, most people in the audience don't care about. The only people who might care about that are the people who are working specifically on that particular problem. That's a very small minority in any broad audience like such as today. So for any presentation, such as conference or like one today, you have to make slides, and you don't want to get confused between the role of the slides and your role when you're delivering a talk. It's very often I have seen people making slides and effectively reading the slides out when they are in person delivering the talk. If all you're doing is mostly reading the slides, why do I need the speaker? I can just look at the slides and that's sufficient. And so the speaker's role is to not just to read out the slides, you can use them, of course, but to add to the slides, expand on it, maybe deliver the information in a different way than the slide might be doing. So next few slides are about how to make slides. Again, these are just rules of thumb that I follow. You can watch other speakers and see what they do and just adopt whatever ideas you like. So this is a question that people debate about actually. If you look at articles on how to give talks, you will see this question being discussed. So for outlines, I don't think you need to have an outline for a 15, 20-minute conference talk. You only have 20 minutes, why waste 30 seconds in outline? For a long talk, yes, I think it's worthwhile. But make the outline interesting. Here is the kind of outlines you see fairly often. It's a completely useless outline. This could be the outline of any talk at all. You don't need an outline like this. It just wastes time. So say something more than the obvious if you do have an outline. Here is an outline that I have used. This is actual outline for a talk I used to give many years ago. And so the talk had 4 parts. You don't need to know what the words mean, but those boxes, those words in those 4 boxes are the 4 parts of the talk. And then as I went from part 1 to part 2, I would tell them which part I was on. So this is what I would show, I would show the outline slide again before I got onto part number 2 of my presentation. This is a little bit more interesting than just having a bunch of words on a slide. Okay, this may be the most important thing I can say about slides. So, and the reason I say it's most important because people violate this all the time. I would say half the talks I go to violate this particular guideline. So my expectation when I'm in the audience is that if there is something on the slide, I need to be able to read it before the speaker goes to the next slide. And if I'm not able to read it, then I feel like I missed something that was important. So if you're not going to give the audience the time to read something, don't put it there. You see folks putting 15 different mathematical equations with full understanding that they're not going to give them time to look at it at all. If you're just trying to impress them with something and you can tell them that, right? Here is a slide, here's a proof. I'm not able to give you the time to read it, but if you want, we can come back after the talk. 1 or 2 slides like that is all right, but not to do stuff like that routinely. So make sure the material on the slide is something they can read while they're listening to you also. If there is too much on the slide, then the audience is looking at the slide, trying to read it, and they're not listening to you anymore. So that defeats the purpose of your talk. And so the slide should have, first of all, the least amount of content necessary, and also not be dense. So here's a slide from one of my own talks that I should have never created, right? I mean, this is terrible. No matter how much time I give you on this slide, this is not a good slide. I remember, actually, this particular slide comes from a tutorial I used to give many, many years ago. It was a day long, I think 4 or 8 hour tutorial, hundreds of slides. And by the time I made this particular slide, I was, I think, just exhausted at making the slides. I got a bit lazy, and this is what I came up with. But this is not serving any useful purpose. It would be so much nicer to break this up into multiple slides, maybe more pictures, so that the reader, the attendee can actually understand things much better. The presentation of a paper is not equivalent to telling the audience everything in your paper. Those are 2 different things. So the published paper will have a lot more detail that you simply cannot deliver in a presentation, and nor should you try to, because it's just too much to absorb in 30 to 60 minutes. So it's okay to skip details. It's okay to wave your hands about certain things, but not too much. And by that, I mean the following. You often see people, and I have done that too, actually, when I did not realize my slides were not good. So here is what happens. I make a slide or many slides, and then I come to a particular slide where I might spend 3, 4, 5 minutes talking about that one slide. And then I find myself waving hands about things that are not on the slide at all. So if I'm going to spend that kind of time on a slide, it would be much better to make many slides, right? Multiple slides, and break down the ideas into multiple slides so I can move from one slide to the next. So if you ever see yourself stuck on one slide for too long, that's probably because the slides were not prepared properly. So slides do not have to be grammatically correct, at least. I mean, they should not be. They should read well, but it's okay to drop an "and" or a "the" every once in a while. It's a slide. It's not a paper. It's not an essay. As long as it gets the point across, that's okay. Use fonts and colors that make sense. At the bottom here, I say not light blue and yellow, and I have actually seen people do exactly that. On your computer screen, it's not a problem, right? Because you can actually read the light blue and yellow. But on a projection screen, this is not at all readable for most people in the audience. So it's important to use good color schemes, font size. This article appeared in New York Times exactly 1 year ago, October 9, 2019. I don't know how many of you know this Comic Sans font. It used to be popular. I have given talks using that font. In fact, that talk from 2010. I was looking at the slides today to remind myself what I did wrong, and it was in Comic Sans too. Although the font is not the reason the talk did not go well. I just did not do a good job. But for some reason, I don't like the font anymore. I used to love it then. And apparently nobody likes it. So if you don't know what it is, perfect, don't use it. As far as slides, we all have PowerPoint, right? It gives you backgrounds and animation and this and that. Try not to do or overdo it. I don't use backgrounds at all, as you can see. I don't use animation anymore, as in the PowerPoint animation, because one time I found that at the last minute I had to switch from PowerPoint to PDF. For whatever reason, some software issues at the machine that the host was using for my talk, and it did not translate well to PDF. It sometimes doesn't translate well from one version of the software to another version of software. So now when I have animation, I just make many slides. I don't use the animation built into the, let's say, PowerPoint. I just create multiple slides to sort of simulate the animation. Avoid blocking the screen. That's not relevant for online talks, but if you deliver something in person, keep that in mind. Actually, I should add something else here, that when you point to something on the screen, this is again in person, don't point to your computer, point to the screen itself that the people are able to see. And again, many of us forget that. Break lines properly. Actually, this applies for titles of papers as well. If you have a long paper title that's going to run into 2 lines, the question is, where should it be split? If you just let's say you're using LaTeX or something like that, if you let it split where it feels like, it's probably going to split it somewhere that is not very pleasant. And here's an example. Actually, the text at the very top, the 2 lines, we had them on a slide much earlier today. And if I had not done any manipulation myself, the bottom 2 lines is what it will look like. It's the same exact words, but at least to me, the 2 lines at the top are much better than the 2 at the bottom, because the top, I'm breaking the line at the right place. And it's a small thing, but it does help the audience. Yeah, I heard this before, picture is worth 1,000 words. And here I'm not grammatically correct, right? I should have said picture is worth 1,000 words. I dropped that one word there. That's deliberate. I don't want you to read any more words than necessary. So use pictures when you can. When you can avoid using words, use pictures. So here is a slide from my actual presentation I have been giving last year or 2 now. So I work on this so-called distributed classification. Intuitively, all it means is that you may have multiple observers in the system. Let's say many cameras or sensors in your system. And each of these cameras is they're looking at an object, or a sensor is measuring something about the environment. That each individual sensor or camera may not be able to tell you, or may not be able to figure out exactly what it is looking at. But when they all collaborate, then they can distributively figure out collectively, right, together, what they're looking at. And I use this slide, which is a well-known story, to define the problem. The paper is very theoretical, but that doesn't mean my description has to be painfully boring. You can actually add pictures. Here is a picture I use also in a talk I give these days to define what I mean by distributed optimization. The details don't matter. I just wanted to point out that you can engage the audience by using, slides that are interesting to them. And once you get their attention, then you can go on to more technical details. Once they feel like they're enjoying the talk, then they will be more amenable to listening to more technical slides. Here is a slide, not that many pictures, but I just want to show you anyhow. So I mentioned earlier that some of the things I do are the intersection of distributed control and distributed computing. And this is my related work slide. I could have written everything in just a bunch of bullets, right? PowerPoint bullets, one below the other. But here it's a timeline, and it shows in parallel the work in control versus computing, how it was happening at the same time. And in fact, just as an aside, these 2 lines of work are happening pretty much at the exact same point of time, if you look at the overlap quite a bit. But until recently, the 2 different communities did not know about each other at all. They had never heard of, the people who know the papers on the left haven't heard of the papers on the right, and vice versa. And that still remains true for a big chunk of the research community, in fact. But what we have been doing is to try to bridge the gap between the 2. So that was the purpose of this slide. Okay, how many slides? That's something people debate as well. I have heard I heard the number 1 to 2 slides per minute. Uh, and some people can give an hour-long talk with 20, 30, 40 slides. In my case, I tend to use more than 1 slide a minute. So for an hour-long talk, I could easily have 100 slides. But the way I can get away with 100 slides, the reason I can get away with it is because, first of all, it's electronic. If I had to physically change, those slides like we did in the old days, you couldn't do that. But it's all electronic now. But more importantly, each of my slides is very low content. There is very little, as you can see today, on any individual slide. And this is why I can move through the slides quite quickly. But this is not for everybody. Not everybody should make 100 slides. Just know your own style and decide how many slides you should have. If you're giving a technical talk, there will always be questions that you can anticipate. If you've done the talk more than once, you can surely think back on the previous talk and prepare answers for the questions that came up. But even otherwise, you can anticipate questions and make slides ahead of time so that it's easier to answer them. So practice, some of us, the senior faculty like me, may not practice the talks, but it's important to practice talks, particularly when the length of the talk is short. I have given talks that are 7 minutes long, for brief announcements. But a typical conference talk is quite short, too, 15 to 30 minutes. And you have to practice because the purpose of a talk is to deliver some amount of information clearly. The goal is not to deliver as much as you can, as much as you can in that time, but deliver what fits in as clearly as possible. And that takes practice, particularly if you're not an experienced speaker. So practice on your own, practice with somebody else if it is a conference talk. And be ready to adapt. In many presentations, you are going to get questions during the talk as well, often. And if the discussion during the talk goes on too long, then you will be short on time towards the end. And so you need to know what you can skip dynamically without breaking continuity of your presentation. And you should also be prepared if the questioners get very aggressive and take too much time in the middle of the talk. You have to know when it is right to tell them to defer the questions, or if they don't defer the questions, defer answering them to the end of the talk. But that's a judgment call you have to make depending on how much time has been lost. If you have an accent like mine, so I had to say, when I listen to myself in my head, I don't have an accent. But when I listen to me on the tape, like this talk, then I know I have an accent. And I know I should talk slower, although it's very hard for me to do that. I have known this for 30 years, but it's not easy to do, but it's something to be aware of. And if you cannot talk slow, then at least, pause every once in a while, let people ask questions. In a technical talk, that's worthwhile because, like I said earlier, if they haven't understood the first half of the talk, the second half may not make much sense either. So it is good to let them ask questions. This is something that a lot of people are not able to do well. So like I said, there will be questions in the talk, and oftentimes, I'm sitting in the audience, I hear somebody's question, and the speaker answers the wrong question. And the reason that happens is that the person who asked the question hasn't understood the talk fully. This may be the first time they're hearing, this kind of material. They don't know how to pose the question in a precise way because this is all new to them. But the speaker should know, right? And that's what I'm trying to say. The speaker should be able to guess what the question is accurately, even if it is posed vaguely. And I don't know how one learns to do that, but some people are very good at this and some are not. And perhaps practice is the way to do it. Give talks, have people ask you questions, and with time you learn how to interpret what somebody is really asking. It's really bad to answer the wrong question. And this I have seen happen in interview talks. When faculty candidates interview, they get asked questions and they answer something. Me and the audience know, actually, even if I'm not the speaker, I sometimes figure out what the question is. And it's obvious to me that the speaker is answering the wrong question. And that doesn't really look good. So if you did not understand the question, don't just answer whatever you think the question was. Ask for clarification. Maybe rephrase the question and say, is this what you meant? And hopefully you arrive at an understanding of what the question really is. So there is no substitute for experience, right? Like I told you, I had given some really bad talks. I'm still regretting them, at least 2 of them. But yeah, every time you give a bad talk, learn from it. Don't make the mistakes you made the first time. And even better, go to other people's talks and don't make the mistake they are making. So that's it. Like I told you before, I'm not going to tell you anything particularly surprising. It's all common sense. But people do ignore a lot of the little suggestions I'm making here. And if you are conscious of this, then when you go to the talks, you will actually notice some of the errors people make and learn from experience. If you like these kinds of preachy talks, then I have one more. I have more than one actually, but this is one that is closer to the talk I'm giving today. It's the talk on how to succeed in academia without really trying. If you go to my website, you can find the slides for this talk as well. And with that, thank you.